Most of us start using AI the exact same way, staring at a chat box, pasting in a few loose ideas, hoping the machine spits out gold. When it inevitably misses the mark, we argue with it, copy the output, tweak it, and paste it back in. It's the digital equivalent of banging two rocks together. You don't have to think hard to do it, but the spark you get is entirely inconsistent, and trying to scale that manual back and forth into an actual workflow is nearly impossible. To solve that inconsistency, developers usually swing to the opposite extreme. They start building massive, chaotic webs of autonomous agents, connecting multiple language models together with heavily engineered infrastructure. Teams will spend months and millions of dollars wiring up these intricate pipelines, all in a desperate attempt to force the AI to execute basic, repeatable tasks without losing its mind. But all that heavy engineering misses the actual problem. We are spending vast amounts of time writing complex Python wrappers and injection harnesses, when we should be looking at how we organize our instructions in the first place. There's a different approach gaining traction right now. Over 30,000 independent developers, along with top researchers at places like Anthropic, are abandoning multi-agent frameworks altogether. Getting highly reliable, complex outputs from an AI doesn't require a labyrinth of code. It requires shifting the complexity out of the software and into the way you structure your plain text. The concept is called the interpretable context methodology. Instead of building software to manage the AI, you simply organize plain text markdown files into a standard folder structure on your computer. Look at a 20-minute argument with a chatbot. It feels chaotic, but structured data is buried there. Strip away casual conversation, and you find logical anchors, user intent, output goals, and tone constraints. Package those into a single markdown file, creating an automated skill. By saving that logic as text, the AI already knows the exact boundaries and requirements for the task. You never have to repeat that exhausting back-and-forth iteration again. This brings us to a much cleaner tier of automation. Rather than forcing a custom script to inject prompts into the AI's context window at specific intervals, you just give one local agent direct read access to your folder system. When you issue a command, the agent acts autonomously. It briefly steps away, opens your tone file, checks your research folder, and gathers what it needs. Doing this drastically cuts down on the computational overhead. Users adopting this method routinely see a 20 to 40% reduction in token usage. The savings happen because you are no longer force-feeding the model an entire unstructured database through retrieval-augmented generation. It only scans the specific markdown files directly relevant to the prompt. You finally stop treating the language model like a confused machine stuck on a rigid, chaotic assembly line, and start treating it like a focused researcher who already has access to a perfectly organized filing cabinet. In an enterprise setting, this organizational shift changes the production timeline. One project used a set of predefined research and scriptwriting folders to bypass a traditional video production contract that typically spans 6 months. Instead of a human director managing dozens of handoffs, the AI navigates these local folders to find your specific voice constraints and animation templates. It produces the raw research, generates a script based on your patterns, and triggers a workflow that renders the final audio and visuals. Because the agent is only pulling the exact text it needs at any given moment, its context window is never overwhelmed. You can scale this coordination across an entire department without deploying massive, costly enterprise servers. As your employees learn to translate their daily logic and constraints into these localized text files, your internal team essentially becomes the vendor, removing the need for external dependencies. But the most compelling proof of concept happens when you scale this beyond a single computer. Imagine joining a group voice call and controlling a colleague's local AI agent and all their local context entirely with your voice. That exact scenario was recently tested by a research team at the University of Edinburgh, who built an engine to run psychometric assessments on large language models. They designed the system to process intense psychological parameters, sending complex questionnaires and even visual tests like the Rorschach inkblot to different models to generate comparative behavioral scores. During a live meeting, a user simply asked the AI out loud what scales were missing. The agent verbally recommended adding dark triad traits. When the user approved it, the agent autonomously read the codebase, updated its own markdown files, and integrated the new scale mid-conversation. We spend years building infrastructure to manage AI's confusion, but organizing your data into a readable folder structure eliminates that friction at the source. The most efficient way to build with AI is to stop coding its workflows and start perfecting its library.